Alright, so we just learned about the cathode ray tube experiments where J.J. Thomson determined the mass to charge ratio of an electron as well as proved the existence of the first subatomic particle. Now what we're going to try and do is look at Millikan's oil drop experiment, which was used to determine the actual charge of the electron, from which we were able to determine mass and actually quantitatively describe that little mysterious particle. So here's how he did it. He had a can, crazy apparatus, and he basically sprayed in little fine mist of oil. Inside the can, he had a positively charged electric plate with a small hole in it and a negatively charged electric plate. And what would happen is, obviously, gravity is going to pull the oil droplets down, and as the ones pass through the hole, they would blast it with a source of X-rays. Now, X-rays are capable of knocking the electrons off of things, which is why they're so dangerous, and you need to wear a lead vest to protect yourself from them. But these oil droplets have no protection. So some of these oil droplets would lose an electron, and some of them would gain. If they lose an electron, they're going to become positively charged and just fall down to the negative plate. If they gain an electron, however, and the electric field is applied, it will actually pull it up towards it. Now, tweaking this device, they were able to get it to the point where the oil droplets would hover and stay static. And at that point, what's happening is the gravitational force, which can be measured, by recording the mass of it, the oil droplet, was equal to the electrical charge being applied above. So at that point, once they got the oil droplets to hover, they could figure out the actual charge of the electron. And by being able to do that, also knowing the mass to charge ratio, they determined the mass of the electron.